Good morning, students. So today here we start a chapter. The name of the chapter is complex number and quadratic equation. So quadratic equation in class 10 already you know what is quadratic equation. So here the chapter is complex number and quadratic equation. So first of all we discuss about complex numbers. So before we start the complex number, if we recall some things here, suppose if you consider an example. For example, if you consider this one, ax plus of b equals to 0. So this type of equations are already we get in class 9, is not it? This one is a linear equation in one variable, is not it? So as you see another equation, suppose ax plus of by plus of c equals to 0. This type of equations are also we get in class 9, which one is a linear equation in two variable. If you see here where a and b are the real numbers. In this way, if you see here, a, b, c are the real numbers and x and y are the variables. So this type of equations are already we discussed, already we know in class 9 this type of equations are we get, is not it? So now after this, if you see a quadratic equation, if you see a quadratic equation in one variable, so the general form of a quadratic equation in one variable is, which one is ax square plus bx plus of c equals to 0. So this one is a quadratic equation in one variable, which one we know, which one we get in class 10. এইখিনি এই দুটা linear equation আমি class 9 ত পাইছিলো আৰু লগতে এই quadratic equation তো আমি class 10 ত পাইছিলো, হয় না? So if we solve this one, then here some roots are we get. If we solve this one by the quadratic formula, we get the value of x here. So to solve this type of equation, some conditions are required. Suppose the nature of roots. Nature of roots, how can we identify the nature of roots? With the help of discriminant. So generally the discriminant is denoted by d, is not it? And the formula is what? Discriminant formula already we know. Which one is the discriminant formula? Is b square minus of 4ac. This one is the formula of discriminant formula, is not it? D equal to b square minus 4ac. So here when we have to solve this b square minus 4ac, some values are we get, like the first condition, these are the known as nature of roots, and here some conditions are we get in class 10. We discussed this one. The first one is if b square minus of 4ac equals to 0, then what happened in this case? We get the roots are real and equal. All of you know this one. As well as if you see the second one, b square minus 4ac, if it is greater than 0, then here also we get real roots and the roots are unequal, isn't it? This story we know. And the third case here we discuss b square minus 4ac is less than 0. That means b square minus 4ac less than 0. In this case what we get? In this we get the roots are not real. That means imaginary. So in class 10 already we discussed this too, and when this type of conditions are we get, simply we write the roots are not possible, impossible or imaginary. So why we write imaginary? Because in class 10 we deal with only real numbers, so that's why we ignore this part. B square minus 4ac is less than 0, imaginary, this part we ignore. Now here in class 11 what you have to do, already this were discussed in 10. So here we deal with this type of condition. If b square minus 4ac is less than 0, if imaginary, so how can we find out the roots? So when we find out this type of roots here, b square minus 4ac is less than 0, imaginary, this type of roots are under, we get the complex number chapter. So that's why here the chapter name given as complex number and quadratic equation. Is it clear? So here mainly we deal with b square minus 4ac is less than 0. So for that here the chapter is given as complex number. Is it clear? Okay. Now here let's take an example. If we consider this example, suppose the example is here we consider x square plus 1 equals to 0. No doubt this one is a quadratic equation in one variable. So if we solve this one, so here what we get here, x square equals to -1, and then in this case if you take the square root, then obviously here this one is a negative value, and in this case if you take the square root, then we get here x equal to root over -1. So which one is what? An imaginary. So in class 10 we stop, and here just we write the roots are not possible because we deal with only real numbers. But in this case, in complex number, what we get here, x equal to root over -1. So here how can we solve this one? For this, the complex number, so first of all what you have to do, let's see, if we denote, let root over -1, if we consider this one is an I, suppose if we consider root over -1 equals to I, if we consider, then squaring both sides, then here what we get, if we squaring both sides, then -1 equals to I square, isn't it? So -1 equals to I square. So if you see here x square equal to -1, if you see this equation, x square equal to -1, as well as here -1 equal to I square. So if we compare these two, then what we get, x square equal to -1, -1 equal to I square. So if you compare these two, then simply we write here x square equal to I square, and from here what we get, x equal to I. So x equal to I is the solution. So for that reason here the complex number, the general form of the complex number is actually what? The complex number, the general form of a complex number, which one we write as an a plus ib. First of all, the complex number, the general form of a complex number is what? A plus ib, and which one we denoted by simply z. The complex number generally denoted by z. Z equals to a plus ib, where this a and b are the real numbers. Remember, where a and b are the real numbers, only I represent here as a complex number. So this one is the general form of a complex number, and this a and b are the real numbers, as well as this one is totally real, so that's why it is known as real part. So this part is known as real part, as well as this ib is known as here imaginary part. This one is known as imaginary part. Is it clear? So this a, in case of this complex number, the complex number is of the form a plus ib, where a is known as real part and this ib is known as imaginary part. And here this a and b are the real numbers, remember, and the value of I is what? I means root over -1. Is it clear? Okay. So here we get the general form of a complex number. The general form of a complex number we get here, z equals to a plus ib, isn't it? So here a is the real part and ib is what? This one is imaginary part. So any number in general form, any number we can represent as a complex number. For example, so z equal to a plus ib. For example, if you consider some example here, suppose we write 2 plus 3i, or if we write i3. So now in this case you see 2 and 3 are the real numbers, as well as here 2 is the real part, as well as 3i is the imaginary part. For example, another one, if you consider, suppose 2 plus minus of 3 into I. If you see here again, second example, 2 is the real part here and I3 minus 3 into I, that means this one is the imaginary part, and here this 2 and minus 3 are the what? Real numbers. So any number we can express as a complex number. For example, 0. So 0 is a real number, and this one if we represent as a complex number, this one we have to write 0 plus I into 0. So when we write I, then it is a complex number. Any real number we can write. For example, if you consider another one, suppose root 3. So you see here root 3 is a real number, isn't it? Plus of, if we write I into root 3. So you see here this one is again a complex number. Is it clear? So when we write any number, so that means it forms, actually we get a complex number form. For example, if suppose if we consider only a number 2, suppose 2 is a real number, is not it? So if we express this one is a complex number form, then what you have to write? 2 plus I into 0. You see here 2 plus I into 0. So 2 and 0 are the real numbers, and here I into 0, ultimately 0, the meaning is what? 2. So each and every number we can express as a complex number. Is it clear? So that's why here the general form is what? A plus ib. The general form of a complex number is a plus IB, and each and every number in our number system we can express as a complex number. Is it clear? Okay. Now under this, now let's take a note here. Suppose if we consider two complex numbers, suppose the first one is Z1 equals to the first complex number, if we consider A plus IB, suppose, and another complex number here we consider, suppose Z2 equal to C plus ID. If anyone asks you when these two complex numbers are equal, so the condition what we get here, if these two complex numbers are equal, for example, if these two complex numbers are equal, suppose Z1 equals to Z2, what are the conditions here we need for these two complex numbers are equal? Jodi duta complex numbers jodi amak dia thake, ami he complex number duta ketia equal boli kom. For here the complex numbers are equal only when the real part equal with real part as well as the imaginary part equal with imaginary part. If we get this condition, then it is known as a complex numbers are equal. In this case, the complex numbers are equal. So the real part to real part or logot equal hoy, as well as the imaginary part to the imaginary part or logot equal hoy. Tikehale a duta complex number ami ki boli kobo parim, these two complex numbers are equal. For that, here if Z1 equals to Z2, if these two complex numbers are already given equal, then here the condition is what we get here, real part equal with real part. Remember, real part to imaginary logot ketiao compare koribo noru. Here real part is equal with real part. Then what we get here, the real part, the A is equal with C. Then here the conditions are we get this one, the real part equal with real part as well as the imaginary part equal with imaginary part. That means here the second condition, B is equal with D. So if these two conditions are we get, then the complex numbers are equal. If the complex numbers are equal, then the real part and imaginary parts are equal. Is it clear? Let's take an example here. Yet an example. Suppose a question given to you. Suppose one question is given here, 4x plus I into 3x minus of y. For example, 4x plus I into 3x minus of y equals to, for example, here written this 4x plus minus of 6 into I. Now already given here, you see, these two complex numbers are equal, already given, if you see. So if this type of one equation given here, 4x plus I into 3x minus of y equals to 4x plus minus 6 into I. So here already you see these two complex numbers are equal given. So if anyone asks you, find out the value of x and y. So how can we find out here x and y? Because here these two complex numbers are already given equal, so that means here the real part is equal with real part, is not it, as well as the imaginary part equal with imaginary part. According to this condition we can write. So that's why here real part is equal with real part. So that means 4x is equal with 4x. If it is not given 4x, then also we can compare here, is not it? So here 4x plus this one, suppose here if you cut this x, so now here this one is a complex number as well as this one is a complex number, is not it? So 4x plus I into 3x minus y, and here we write 4 plus minus 6 into I. So now in this case, if you compare this 4x equal to 4, then from here what we get, x equal to 1, is not it? So in this way we can find out. And here the imaginary part is equal with imaginary part. So imaginary part is what here, 3x minus y. So that means if we write this one is 3x minus y, this one is equal with minus of 6. So here the imaginary part is 3x minus y, as well as the imaginary part is here minus 6. So if we compare these two, we get this type of result. So our question is what here, we have to find out the value of x and y. So already if we compare 4x equal to 4, then we get the value of x is 1, and this x value if we put here, then this one we get here 3 into 1 minus of y equal to minus of 6. And from here what we get here, if you shift this 3, minus 9, and that ultimately y equal to we get here 9, isn't it? So in this way we can find out the value of x and y. When two complex numbers are given equal, then easily we compare the real part and the imaginary part. So this one is about the equality of two complex numbers, or when we can say here two complex numbers are equal. If two complex numbers are equal, in this way we can find out the value of x and y. I hope all of you understood here. So today what we discuss about the linear equation in one variable, linear equation in two variable, which two are already we know in class 9, and with this we discuss about the quadratic equation as well as the nature of roots, isn't it? And after that, when we write down the general form of a complex number, the general form of a complex number is what? A plus IB, isn't it? Where A is the real number as well as B is the real number. And if we write the general form, Z is the complex number is generally denoted by Z, so Z equal to, we write A plus IB, where A is the real part and IB is the imaginary part. And after that we discuss about when two complex numbers are equal, then easily we can compare, and in this way we can find out the value of X and Y. So I hope all of you understood this one. So in our next class we discuss about the algebra of complex numbers. Very interesting point this one. So in our next class we discuss about the algebra of complex numbers. That's all for today. Is it clear? Okay, thank you.